Hi friends, welcome back to our series of sessions that we have been doing on YouTube with a mission motivate million minds. Today topic is on Smart India Hackathon 2024 announced by the Ministry of Education, Government of India under Ministry of Education Innovation Council program. The main challenge for any participant of this Smart India Hackathon 2024 is understanding the problem statements. Today, I am here to discuss some problem statements, both hardware and software, so that it will be useful to the novice participants of the Smart India Hackathon 2024. Basically aimed at enabling the students, enabling a cultural shift in the student community, and enabling open innovation in the society that will anchor for hackathons in the country. With these objectives, the Smart India Hackathon is going to be held during the third week of September 24. So for this reason, let's discuss some of the problem statements. So the first problem statement is on development of a non-electrical device for tracking the movement of the sun, for movement of the solar panels, increasing their efficiency. This is the problem statement ID with 1545, mainly for the Department of Science and Technology. We have divided the problem statements into background, description, and expected solution. So for every problem, the 15 problems which we will be discussing now, we will have the classification based on the background of the problem statement, the description of the problem statement, and expected solution out of it. So the background is basically solar panels are most efficient when they are directly facing the sun. However, sun's position changes throughout the day and across seasons, which can reduce the amount of sunlight that fixed solar panels receive. So the description is traditional solar tracking systems often rely on electrical components and motors, which can be costly and require maintenance. A non-electrical tracking system offers a sustainable and low maintenance alternative to enhance the efficiency of solar panels. The expected outcome for this should be to develop a cost-effective, non-electrical device that can accurately track the sun's movement and adjust the orientation of solar panels to maintain optimal exposure to the sun. This device should be reliable, easy to install, and capable of operating without external power sources. So the next problem statement is development of innovative design for flushing systems in Western toilet sheets, which can be used for deployment in public toilets, with a problem statement of 1546, and the supporting organization is Department of Science and Technology, Government of India. So the background here is public toilets are essential for maintaining hygiene in urban areas, but they often face challenges such as high usage, maintenance issues, and water wastage. So the expected innovative solution is an innovative public toilet design which is required so that maximum usable area gets cleans during the flushing and can be automated in a mechanized form. It need not be non-electronic, so that after the usage, the flushing system gets activated automatically and the whole usable area gets cleaned. That's the problem statement 2. So the problem statements 3 is with the PS ID of 1547, again sponsored by Department of Science and Technology, is on development of an alternative technology to check blockage of blood vessels, which is an alternative to conventional angiography. So the background is basically angiography is a common medical imaging technique used to visualize the inside of blood vessels and detect blockages. However, typically medical tests like radionuclide angiography involve the use of radioactive contrast agents, which can pose risks to patients, including radiation exposure and allergic reactions. There is a growing need for safer, non-invasive alternatives that can provide accurate diagnostics without these risks. So the expected solution is to develop a cost-effective, non-invasive technology that can accurately detect blockages in blood vessels without the use of radioactive materials. This technology should be suitable for widespread clinical use and provide reliable results comparable to conventional angiography. So the fourth problem statement with an ID of 1548, again sponsored by Department of Science and Technology, is the development of a suction-based low-cost flush with less water usage for deployment in rural areas. As we all know, access to proper sanitation facilities is a significant challenge in many rural areas. Traditionally, the traditional flush toilets require a substantial amount of water, which may not be readily available in these regions. Additionally, the cost and complexity of installing conventional plumbing systems can be prohibitive. A suction-based flush system is required, which offers a potential solution by reducing water usage and simplifying installation and maintenance. So the expected solution is to develop a cost-effective suction-based flush system that can be easily deployed in rural areas. The system should minimize water usage, be simple to install and maintain, and provide a hygienic and effective means of waste disposal. So the fifth problem statement is on development of chemical strip, which is non-electric, for identification of high temperature exposure in transportation of medicines, vaccines, FMCG goods to ensure its usability. The problem statement ID is 1549, again sponsored by Department of Science and Technology. The transportation of temperature-sensitive goods is a critical aspect of supply chain management. Medicines, vaccines, and certain FMCG products require strict temperature control to maintain their efficacy and safety. Exposure to high temperatures can compromise these products, leading to potential health risks and financial losses. Traditional electronic temperature monitoring devices can be costly and may not be feasible for all types of shipments. The expected solution is to develop a cost-effective non-electronic chemical strip that changes color or exhibits a visible change when exposed to temperatures above a certain threshold. This strip should be easy to use, reliable, and capable of providing a clear indication of temperature breaches during transportation. The sixth problem statement, ID 1540, again sponsored by Department of Science and Technology, is the development of a portable device, a non-contact type, for measurement of eye pressure in glaucoma patients for usage at home. As we all know, glaucoma is a leading cause of blindness all over the world, and managing intraocular pressure, we call it as IOP, is crucial for preventing disease progression. Traditional methods of measuring IOP, such as Goldman applantation tonometry, require direct contact with the eye, topical anesthesia, and skilled personnel, making them less accessible for regular monitoring. Non-contact methods such as air puff tonometry offer a more convenient alternative, but are often limited to clinical settings due to their size and cost. So the expected solution is to develop a cost-effective, portable, and non-contact device that can measure IOP accurately and reliably with safety. This device should be easy to use and allowing patients to use at home also. So the sixth problem statement, number 1555, basically sponsored by Ministry of Ayush, Ayurvedic, Unani, allopathic, Unani, and the Siddha and homeopathy. It's basically to create a virtual herbal garden that provides an interactive, educational, and immersive experience to users, showcasing the diverse range of medicinal plants used in Ayush. The Ayush sector relies heavily on medicinal plants and herbs, which form the backbone of traditional healing practices. However, physical gardens that are not accessible to everyone. A virtual herbal garden will bridge this gap by offering a digital platform where users can explore, learn, and understand the significance of various medicinal plants from the comfort of their homes. Participants are tasked with developing a virtual herbal garden that is engaging, informative, and user-friendly. This virtual garden should include interactive 3D models, realistic 3D models of medicinal plants that users can rotate, zoom, and explore from different angles. So the expected solution is a comprehensive virtual herbal garden that serves as a valuable educational tool for students, practitioners, and enthusiasts of the Ayush sector. This platform should make the knowledge of medicinal plants accessible to a wider audience, promoting awareness and understanding of traditional herbal practices. It should be visually appealing, informative, and interactive, providing users with an immersive experience that combines technology with traditional knowledge. Next, problem statement 1556, again from Ministry of Ayush, is to develop a smart yoga mat integrated with artificial intelligence, capabilities to support smartwatch integration for tracking progress and provide curated yoga content by experts while ensuring its affordability. As we all know, yoga has gained global recognition for its numerous health benefits, including physical fitness, mental well-being, and stress reduction. As part of India's ancient heritage, yoga is a key component of the Ayush systems of medicine, promoting holistic health practices. In today's digital age, there is a growing demand for innovative solutions that combine traditional practices with modern technology. A smart yoga mat equipped with AI and smart watch integration presents an opportunity to enhance the yoga experience, making it more interactive, personalized, and accessible. The objective of this challenge is to design and develop a smart yoga mat that leverages artificial intelligence capabilities to smartwatch integration, enable seamless connectivity with smartwatches to track key metrics such as heart rate, calories burn, and workout duration. In this integration, intended to provide real-time feedback to users, helping them monitor their progress and adjust their practice accordingly. AI-powered guidance is to utilize AI algorithms to analyze user data from the smartwatch and provide personal recommendations for yoga routines. The smart yoga mat should be capable of offering curated content, including instructional videos, audio guidance, and posture corrections based on individual performance metrics. Ensure that the smart yoga mat remains cost-effective without compromising on quality or functionality. The expected solution is to deliver a prototype of the smart yoga mat that demonstrates seamless integration with smartwatches for tracking yoga-related metrics, AI-driven capabilities for personalized yoga guidance and content recommendations, user-friendly interface, and ergonomic design suitable for various yoga practices, cost-effective manufacturing, feasibility suitable for Ayush startups is preferable. So the ninth solution with a problem with an idea of 1562, sponsored by Narcotics Bureau of Government of India, is to have solution for end-to-end tracking of dual-use chemicals used in both legitimate industries and illicit drug production from point of manufacture to point end use or export. So dual-use precursor chemicals are substances that have legitimate industrial and commercial applications, but can also be used in the illicit manufacture of drugs. For example, opium is converted into heroin using acetic anhydride, and manufacturing of methamphetamine is drug done using ephedrine or pseudoephedrine. Precursor chemicals are essential in various legal industries such as pharmaceuticals, agriculture, and manufacturing, etc. But their potential for misuse necessitates strict regulation and monitoring. It is observed that some of the firms with valid URN to be handled any of the 7 domestically controlled precursor chemicals divert the same from illicit channel and traffic it for manufacturing of narcotic drugs or psychotropic substances. Further, the investigations conducted also reveal that the user firms usually create a documentation of the movement of precursor to illicit from for a licit activity and divert the same for illicit activities. Therefore, there is a need for end-to-end tracking of the 7 domestically controlled precursor chemicals. So the expected solution is to have a hardware or software or chemical solution for end-to-end tracking of dual-use chemicals used in both legitimate industries and illicit drug production from point of manufacture to point of end use or export. So the 10th problem statement with an idea of 1563, sponsored by National Technical Research Organization. It's basically on automatic change detection in synthetic aperture radar satellite images. Synthetic aperture radar satellite images have the capability for nighttime imaging as well as imaging without being affected by clouds. Automatic change detection on such images have wider application for various use cases. We all know change detection between two SAR, synthetic aperture radar, satellite images are straightforward if they are co-registered as the difference or the ratio of corresponding pixels of the two images itself will give the change map. But such change maps will invariably have many natural changes as well, like water body extent, flood extent, snow cover, and forest cover changes, etc. Our interest is to detect only man-made changes and avoid natural changes. The solution can make use of Sentinel-1 SAR open source satellite images and Google Earth Engine platform to access them. These images are co-registered by default. The GRD, Ground Range Detected Intensity Image version of the Sentinel-1 SAR is to be used. Please note that images with same viewing geometry are better suited for change detection purposes. The solution should give the option for the user to vary the thresholds, if any, used for filtering the change results. The change output should be in the form of polygons in a geographically referenced vector file. The solution should be scalable, means should be able to run on huge areas of interest and generate change alerts. The criteria for winning solution would be minimum false alarms with regard to man-made changes. So the expected solution is a software-based solution is expected that has a graphic user interface to specify the area of interest for change detection and threshold controls to filter changes and output changes in the form of shapefiles with geographical references. It shall run above Google Earth Engine. So the next problem statement, again for National Technical Research Organization with a problem statement of 1565, is target detection by optimizing anomaly detection in hyperspectral image processing using artificial intelligence and machine learning. Hyperspectral imaging acquires images with very narrow continuous wavelength ranging from UV to LWIR, which is beyond the visible spectrum. Using this continuous spectral information classification of diverse material of interest can be done accurately. The availability of huge information due to continuous spectral information improves data information content, but causing challenges in processing of hyperspectral images. An unsupervised learning mechanism for detection of targets by optimizing anomaly detection in hyperspectral imaging processing using AI or ML can be used for it. The above problem statement envisages that hyperspectral data to be processed in such a way that to find spectrally distinct and most informative pixels in the data to identify anomalies in the data. Before processing of data correction methods to improve interpretation of pixel spectra and better result to analyze the data can be done. Different approaches for denoising to remove noise from data, fusion approach through sharpening or pan sharpening can be implemented. The calibration of data using radiometric and atmospheric correction methods can be implemented to optimize the result. An anomaly detection model based on deep learning with best performance to be implemented to process hyperspectral data, which can provide clear identification of anomalies in the data with sufficient spectral clarity. Subsequently, the same can be created as spectral signatures of the objects. A suitable target detection methodology for identifying target of interest is also to be developed. The expected solution is to have a deep learning models for processing of hyperspectral data based on anomaly detection to be optimized that can be used for target detection in that data using available open source hyperspectral data of Hyperion, VIRIS, etc. to be developed. The 12th one is enhancing body detection in CSSR operations using advanced technology with a problem statement of 1566 of NDRF, National Disaster Relief Forum. During CSSR, that is Collapsed Structure Search and Rescue, that's the short form of CSSR operations, NDRF teams encounter challenges in identifying buried, deceased bodies amidst rubble and debris. traditional search methods are often time-consuming and labor-intensive, hampering the timely recovery of victims and increasing the risk of further casualties. The problem statement envisions the need for innovative technology to improve the detection and identification of buried deceased bodies during CSSR operations. Current methods such as manual probing, canine search, and acoustic sensing have limitations in accurately locating victims, especially in complex and hazardous environments. An advanced technology is expected solution leveraging hardware and software innovations to enhance deceased body detection capabilities. This solution could involve the development of specialized sensors, imaging devices, or drones equipped with thermal imaging and ground penetrating radar technology. These tools would enable NDRF teams to scan debris piles and collapse structures, more effectively identifying buried bodies with greater accuracy and efficiency. So these are all some of the problem statements. So thank you very much for your